Hi guys, welcome to another episode of Learn with Sir Glenn, and for this video we're going to discuss factoring polynomials using synthetic division. So let's go! So before proceed with the topic, let's have first a review of factorings that we're going to use in our lesson. So first is the common monomial factor. So factor the following by getting the common monomial factor. So the common monomial factor is the greatest common monomial factor between the terms of the given expression. Let's have 4x plus 8. Common monomial factor of this is 4. Since we can divide 4x and 8 with 4, then that will be our common monomial factor. So therefore, if we're going to factor this using common monomial factor, we will have 4 times x plus 2, where 4 is the common monomial factor and x plus 2 is the other factor when you factor out the common monomial factor 4. So let's have another one, x squared minus 5x. So for this one, the common monomial factor is x. So since x squared and 5x are both divisible by x, so we will have x times x minus 5, and x is our common monomial factor while x minus 5 is the other factor. So this can be obtained by dividing x squared minus 5x by the common monomial factor x. So next, let's have 2x cubed plus 6x squared plus 8x. So the common monomial factor for this is 2x. So therefore, if you factor this using the common monomial factor, we will have 2x times x squared plus 3x plus 2. Now let's have x cubed minus 6x squared plus 8x raised to 4. So for this one, the common monomial factor is x squared. So we will now have x squared times x minus 6 plus 8x squared for the factors using the common monomial factor. Now let's have factoring quadratic expressions. So factor the following quadratic expressions. So let's have x squared plus 5x plus 6. So we all know that when you factor quadratic expressions like this, the factors will be composed of two binomials. So for this one, we will have x plus 2 times x plus 3, where in your two binomials, the first terms of this are from the factors of x squared, which are x, and the second terms of your binomials are from the factors of 6. So although we have here set of factors for 6 as 1 times 6 and 2 times 2, we're going to choose the factors of 6 that when you add, you will have the middle term, which is 5. So for this one, we will have 2 and 3. So let's have the next one. So x squared minus 2x minus 15. So we're going to factor this as product of two binomials. So the first term will be from the factors of x squared, which are x, and then the second term of the binomial will be from the factors of negative 15. So for this one, we will have x minus 5 times x plus 3. So negative 5 times 3 is negative 15. At the same time, when you add negative 5 plus 3, you will have negative, which is the numerical coefficient of the middle term of our quadratic expression. So now let's have x squared minus 16. So this example is actually difference of two squares, and when you factor difference of two squares, you will have product of sum and difference of binomials. So to get the factors, you just simply get the square root of the first term, then square root of the second term, then that will give us x and 4. So we get the sum and difference, we will have x plus 4 and x minus 4. So let's have x squared plus 4x plus 4. So this time, we're going to have perfect trinomial square. So we will have x plus 2 times x plus 2, or x plus 2 squared. If you want to factor quadratic expressions, so you can just simply have the method that we had on our review. But how to factor polynomials with degree greater than 2? Let's try to find the factors of p of x equal to x cubed plus 3x squared minus 6x minus 8. You can actually find the factors of this polynomial using synthetic division, factor theorem, remainder theorem. But for this one, we're going to use the synthetic division. So when you look for the factors of your polynomial, you have to also consider the degree of your polynomial. The degree of your polynomial will determine the maximum number of factors that you can have on your polynomial. Here are the steps in finding the factors of polynomial with degree greater than 2 using synthetic division. So step 1 is to check for the common monomial factor and factor it out. Step 2 is to arrange the polynomial in descending power of x and use 0 to fill any missing term. Step 3 is to list all the factors of the constant term. Step 4 is to use synthetic division to find the correct factors via trial and error. Then step 5, write the polynomial in factor form. So now let's try to apply the steps in finding the factors of p of x equals x cubed plus 3x squared minus 6x minus 8. So step 1, check for the common monomial factor and factor it out. So on our given polynomial here, there's no common monomial factor, so we can now proceed with step 2, which is arrange the polynomial in descending power of x and use 0 to fill any missing term. So we will have our polynomial as x cubed plus 3x squared minus 6x minus 8. It's already arranged in descending power of x, so you don't have to rearrange. Step 3 is to list all the factors of the constant term. On this polynomial, the constant term is negative 8. So what we're going to do is to just simply list all the factors of negative 8. And that will give us positive negative 1, positive negative 2, positive negative 4, positive negative 8. So if you're not familiar with the factors of negative 8, these are pair of numbers that when you multiply will give you 8. So for this one, we have the pairs 1 and 8, which when you multiply 8, and 2 and 4, which when you multiply is also 8. Step 4, use synthetic division to find the correct factors via trial and error. So we're going to set up our synthetic division, and on our first row, we're going to write the numerical coefficients of our given polynomial. So 1, 3, negative 6, negative 8. So what we're going to do is to perform the synthetic division and make sure that the last digit on the third row is 0. Because if the last digit on the third row is 0, then your P of C, which is your remainder, is 0, then the expression that you use on your synthetic division to divide your polynomial is a factor of that polynomial. So this is a trial and error method, so meaning if you're going to look at the box on our synthetic division, there is no number. So what we're going to do is to put a number on that box, then you try it if you will have a 0 on your third row last digit. If it's not 0, you're going to replace that number with another number. Then you try it again until you have the last digit on the third row is equal to 0. So where can we get our numbers that we're going to put on that box? That will be from the factors of negative 8. So therefore, we're going to choose from the numbers positive negative 1, positive negative 2, positive negative 4, positive negative 8. So for this one, we can have the negative 1. So, performing the synthetic division, we bring down 1, we multiply negative 1 times 1 is negative 1, we add 3 plus negative 1 is 2, then negative 1 times 2 is negative 2, add negative 6 plus negative 2 is negative 8, negative 1 times negative 8 is positive 8, add negative 8 plus 8 is 0. So, since this one is 0, then negative 1 will give one of the factors of x cubed plus 3x squared minus 6x minus 8. So now, looking at the third row of your synthetic division, since we only have here 3 remaining numbers, which are 1, 2, and negative 8, so we can just simply express this in quadratic expression. So we will have x squared plus 2x minus 8, and since this is quadratic expression, we can factor this the same way with what we did on our review. So we will have two binomials, so the first term will be from the factors of x squared, and the second term will be from the factors of negative 8, that when you add, we will have 2. So we will have here x minus 2 times x plus 4. Then after this, we're going to proceed now with step 5. So we write the polynomial in factor form. So our polynomial now will become p of x equal to x plus 1 times x minus 2 times x plus 4. So where did we get x plus 1? So the x plus 1 is actually from your negative 1 on your synthetic division. Since negative 1 gave us 0 on the last digit on the third row of your synthetic division, then the expression that we use to divide our polynomial using synthetic division is a factor of that polynomial. So you simply write it in the x minus c form, then we will have it as x plus 1. Then the x minus 2 times x plus 4 are the factors that we're able to get from the quadratic expression x squared plus 2x minus 8. Okay, so let's have another example. Find the factors of p of x equals x raised to 4 plus 9x cubed plus 26x squared plus 24x. So step 1 is to check for the common monomial factor and factor it out. So since on our p of x equals x raised to 4 plus 9x cubed plus 26x squared plus 24x, we have a common monomial factor which is x. So we factor it out. So we will have p of x is equal to x times x raised to 3 plus 9x squared plus 26x plus 24. So we're going to set aside the common monomial factor, then we're going to work on the other polynomial. So step 2 is to arrange the polynomial in descending power of x and use 0 to fill any missing terms. So x cubed plus 9x squared plus 26x plus 24 is already arranged in descending power of x, so therefore we're going to proceed to step 3. These are all the factors of the constant terms. So since we set aside our common monomial factor, then our constant term now is the 24. So we're going to list the factors of 24. We will have positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, positive negative 8, positive negative 12, and positive negative 24. Then, after this, we're going to proceed to step 4, use synthetic division to find the correct factors by trial and error. So, we're going to set up our synthetic division. And on the first row, we're going to write the numerical coefficients of x cubed plus 9x squared plus 26x plus 24. So, we will have 1, 9, 26, 24, setting aside the common monomial factor. So our aim here is when you apply the synthetic division, our last digit on the third row will become 0. So we're going to pick numbers from the factors of 24 and we're going to put it on the box, then apply the synthetic division and hope that we will going to have 0 on our last digit third row. If it is not 0, we just simply replace it with another numbers from the factors of 24. Okay, so let's have here negative 2. So we're going to bring down 1. Multiply to negative 2, that's negative 2. Then we're going to add. So 9 plus negative 2 is equal to 7. Negative 2 times 7 is negative 14. Add will give you positive 12 times negative 2 is negative 24, and that will give us 0. So since this is 0, then negative 2 will give one of the factors that we're going to look for, x raised to 4 plus 9x cubed plus 26x squared plus 24x. And since we only have 1, 7, 12 on our third row, we can just simply express this in quadratic expression. And that will give us x squared plus 7x plus 12. Then we just simply look for the factors of this quadratic expression. So we will have x plus 3 and x plus 4. Then all we have to do is to write our polynomial in factor form. So that will give us p of x is equal to x. That is common monomial factor that we set aside a while ago. Then we have x plus 2. That is from the synthetic division. That is from the negative 2 that we use in the synthetic division. You just simply write it back to x minus c form, and that will give us x plus 2. Then the x plus 3 and x plus 4 are from the factors of quadratic expression x squared plus 7x plus 12. So the factors are x times x plus 2 times x plus 3 times x plus 4. Let's have our last example. Find the factors of p of x equals x raised to 4 minus 9x squared plus 4x plus 12. So step 1 is to check for the common monomial factor and factor it out. So since there's no common monomial factor for this one, we proceed with step 2. Arrange the polynomial in descending power of x. Use 0 to fill any missing term. So therefore, we will have x raised to 4 plus 0x cubed minus 9x squared plus 4x plus 12. So putting 0x cubed in place of the missing term x cubed. Then after this, we list all the factors of the constant term. Our constant term here is positive 12. So the factors are positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, and positive negative 12. Step 4, use synthetic division to find the correct factors via trial and error. So we're going to set up our synthetic division. So we will have 1, 0, negative 9, 4, and 12. So our aim is to have the last digit on the third row equals 0. So we're going to choose number from the factors of 12, which we're going to put on the box of our synthetic division. So for this one, we're going to have negative 1. So we're going to perform the synthetic division. So bring down 1, multiply negative 1 times 1 is negative 1. Add, so that will give us negative 1. Negative 1 times negative 1 is positive 1. Add, that is negative 8. Negative 1 times negative 8 is 8. Then add, that will give us 12. Negative 1 times 12 is negative 12. Then we will have here 0. Since it is 0, then negative 1 will be one of the factors that we are looking for. So after this, looking at the digit on the third row, we still have 1, negative 1, negative 8, and 12. This will not give us a quadratic expression yet, so what we're going to do is to perform another synthetic division. We're going to pick again a number from the factors of 12 to put in the box. Then we perform the synthetic division and hope that we have 0 for the last digit on our third row. So we will have 2. So bring down 1, so that is 2 times 1 is 2, add, so negative 1 plus 2 is 1, then multiply 2 times 1 is 2, add, we will have negative 6, 2 times negative 6, negative 12, so we will have 0. So since this is another 0, then 2 will give us also another factor of x raised to 4 plus 0x cubed minus 9x squared plus 4x plus 12. So since we only have here 1, 1, negative 6, we can now express this in quadratic expression x squared plus x minus 6. Look for the factors. We will have x minus 2 times x plus 3. So all we have to do now is to write the polynomial in factor form. So we were able to get x plus 1 from the negative 1 that we use in the synthetic division, x minus 2 from the 2 that we use in the synthetic division. You just simply rewrite it back to x minus c form. Then we have x minus 2 times x plus 3 from the factors of x squared plus x minus 6, which is our quadratic expression. So the factors of x raised to 4 minus 9x squared plus 4x plus 12 are x plus 1 times x minus 2 times x minus 2 times x plus 3. Or you can also have x plus 1 times x minus 2 squared times x plus 3. Okay, so that's it. Thank you for watching and hope you have learned something from this video.